Okay, so the first couple questions say evaluate the sigma notation expressions by expanding and adding. And so what we need to do is we need to put in all of the values for n, the index, and see what we get out when we put them into n. So let's rewrite everything first. So 2 plus 3 times 1 minus 1. We're going to put 1 in first because that's the lower bound. 2 plus 3 times, next we do 2 minus 1, and we work our way all the way up to where we get to the upper bound. And I need to do one more. And since I got to 6, that's the upper bound, that tells me it's time to stop. So then I need to figure out what each of these are, and then I need to add them together. So this is where I'm going to use my calculator. So I'm going to type in 2 plus 3 times 1 minus 1, like that, and then hit enter. And I get 2. I'm going to just go up and hit enter to copy that down, and then I'm going to change the 1 to a 2. And I'm just going to do that the whole way down. Now, I notice already I have a pattern here. So I'm adding 3 each step, so then I can just go to that pattern and say, okay, then that means that I have to have 11, and then 14, and then 17. The last part is now I just need to take all these numbers and add them together. So 2 plus 5 plus 8 plus 11 plus 14 plus 17 in my calculator, and I get 57. That's my answer. Same process on this one, except my lower bound is 2, so I start with putting 2 in for n. So 15 minus 6 times 2 minus 1. And I stop because my 4 matches my upper bound now. So now I evaluate using my calculator. And I notice the pattern is minus 6, so then I subtract 6. So what do I get when I add these 3 numbers together? I get, well, 3 plus negative 3 is 0, so then I just have 9. My answer is 9. Okay. These ones say I'm using the formula right here. Remember that n is the number of terms, a1 is the first term, and then an is the last term. So let's figure out what a1 is, an is, and what n is for each term. So for each problem. So n is the number of terms we're adding. If we're going from the first term to the 10th term, I'm adding the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th term. That's 10 terms. So I need to figure out that there are 10 terms I'm adding together. So n is 10. an then is going to be a10. So that's the 10th term in the sequence. a1 is the first term in the sequence. So I can look at my formula and recognize that a1 is 24. Or you could put in 1 for n and see what you get out. To get a10, I'm going to put in 10 for n right here and see what I get out. So 24 minus 4 times 10 minus 1. 10 minus 1 is 9. 9 times 4 is 36. 24 minus 36 is negative 12. Let's just check that in our calculator. 24 minus 4 times, and I'm just going to write 9 because that's what 10 minus 1 is. Negative 12. So I'm done. So then I need to use this formula. So let's rewrite. n is 10, a1 is 24, plus an is negative 12, all over 2. So then I get 24 plus negative 12 is 12. 12 times 10 is 120, divided by 2 is 60. So my answer here is 60. This one, same process. I need to identify A1, an, and n. A1 is written in the formula, it's 6. It's also what you get when you put in 1 for n right here. N is the number of terms you're adding, so from the first term to the 8th term, that's 8 terms. An is A8 then. So A8 is 6 plus 7 times 8 minus 1. 8 minus 1 is 7, so 7 times 7 is 49. And then I do 6 plus 49 is 55. So my answer is what happens when I use this formula. So Sn equals, n is 8 times 6 plus 55 divided by 2. 6 plus 55 is 61. 61 times 8 is 488. Divide by 2. And I get 244. There's my answer. Okay. On these, we're also going to use the same formula. So I'm going to write my formula over here. Sn equals n times a1 plus an over 2. This time we have different information that we know. And so we know that n equals 10 for this problem. We're adding 10 terms together. We know our first term, but we don't know an. So what we need to do is we need to write a sequence formula for it and use n, a1, and what I find for the common difference to write my formula. So common difference is negative 3 because we're subtracting 3 each step or adding negative 3 each step. So an equals 45 plus negative 3 times 10 minus 1. So I put my 10 here for n, put my negative 3 for d, and I put my 45 for a1. I'm just going to take my calculator and use my calculator to do this. So 45 plus negative 3 times 10 minus 1. And my answer is 18. So now I have an, a1, and n. So Sn equals 10 times 45 plus 18, all divided by 2. 45 plus 18 is 63. 63 times 10 is 630. Divided by 2 is 315. Okay, last one, but this is the same process as number 3. So n is 80. A1 is 1. An is what we need to find. Use our sequence formula. We know n, we know a1, we can find d. It looks like it's 2 each step. So That's what I'm going to put in. And when I use my calculator, 1 plus 2 times 79, I get 159. So then Sn is 80 times 1 plus 159 over 2. And I get 6,400. And I'm done.